Chapter 5, page 203. Chapter 5, page 203. Part 4. Much like the dynamic considerations required during each phase of the OPT model, the sports performance professional must make decisions regarding training stress, rest, and recovery in acute variable manipulation through each stage of metabolic energy system training. Acute metabolic energy system training variables include modality, intensity, duration, and frequency. Each acute variable influences the others, making this an integrated process. For instance, higher intensities generally require reduced workout durations. Several high-effort workouts in a single week will require greater recovery between sessions, and thus a reduction in a training frequency. The key is applying the right amount of stress with proper recovery between training sessions. Repeated over time, this process leads to improved metabolic energy system, fitness, and performance. Assessments. Metabolic testing can help identify strengths and weaknesses, providing a benchmark for monitoring improvements over time. Lab-based testing can provide a very detailed evaluation of fitness. However, it requires expensive equipment and a great deal of advanced training to interpret the results. In light of this, field tests have been developed to assess individuals' fitness without the need for lab equipment. Research in focus. 12-minute walk-run test. The 12-minute walk-run test functions as an accurate assessment method to use with any performance athlete. A thorough meta-analysis examined the validity of many different field tests commonly used to evaluate metabolic energy system fitness and concluded a thorough meta-analysis examined the validity of many different field tests commonly used to evaluate metabolic energy system fitness, and concluded that 12-minute walk-run test represents one of the most useful alternatives to lab-based measures for estimating metabolic fitness. Age, sex, fitness level do not seem to alter the validity of the test. Thus, it can be used in various populations for athletes. The assessment should be performed on a 400-meter track with the athlete instructed to walk or run as fast as possible in 12 minutes. The tester will count total number of laps completed and mark the finishing point in order to calculate the additional meters of the final incomplete lap. Total distance in meters is then converted to kilometers, meters 1,000, and entered into the following equation to predict VO2 max. VO2 max equals 22.351 times distance in kilometers minus 11. While monitoring changes in fitness over time is primarily importance, the VO2 max of an athlete can be compared to percentile ranks in interpret and evaluate current fitness level. Those with higher levels of beginning fitness will then be able to start training at a higher level. Page 205. A heart rate monitor worn during the assessment may also provide useful information to track progress and identify changes over time. Monitoring heart rates provides valuable information regarding training effects. As an example, fitness continues as an athlete's fitness continues to improve, heart rate during maximal and submaximal efforts will change over time, signifying greater efficiency during exercise. When incorporating heart rate zone training, comparison of heart rate patterns during VO2 max testing can help validate the training zone. Heart rate may decrease at the same test pace over time, signaling an improved metabolic function and the ability for the athlete to push even harder. Conversely, if the exercise heart rate increases along with pace, that might reflect improved muscular endurance and signal the need for additional training in metabolic efficiency. High intensity zone 3, high intensity zone 2 intervals. This information is important to monitor during training in order to verify training effectiveness and to become more familiar with athletes. Modes of metabolic energy system training. Modes of metabolic energy system training. The first consideration in the programming of the metabolic energy system fitness is the selection of proper training mode. Research has shown very little difference in general metabolic energy system improvements when comparing activities such as running, cycling, swimming, and elliptical. However, performance improvements appear to be specific to the mode of training. This means that, for example, if improvements in cycling performance are desired, cycling should be primary mode of training. Cross-training, i.e., the use of modes other than those involved in competition, can be beneficial to present a unique variation in stress, while avoiding repetitive stress injuries. Although specificity of training should be considered when specialized adaptations are necessary. For athletes competing in a specific activity, the greatest correlation of fitness training to performance will be seen when the sport of choice is primary mode of exercise. For example, while swimming and cycling may be effective in developing general fitness, running will have a greater influence on performance during run-based sports. Thus, athlete whose sport involves running, examples, football, baseball, soccer, should perform the bulk of their metabolic energy system training in the form of course, running. So if your sport is running, you gotta run. If your sport is cycling, you gotta cycle. But I would totally still cross-train. Each cardio modality has a specific stress it applies to the body, making each one unique in regard to the amount of muscle tissue activated and the specific muscle groups recruited during the activity. However, the metabolic stress of each modality is related more to the volume and intensity of training rather than the specific activity. A heart rate of 150 beats per minute while road cycling represents the same level of metabolic stress as 150 beats per minute while running. The amount of muscle tissue activated during running, however, is greater that of cycling due to increased involvement of the upper body and additional lower body impact forces. Therefore, heart rate is often higher during running than cycling, representing a greater overall metabolic demand. Therefore, heart rate is often higher during running than cycling, representing a greater overall metabolic demand. Similarly, activities that require both upper and lower body muscle activation, swimming, rowing, have the potential to further increase the metabolic demand due to higher rates of muscle tissue recruitment that forces the body to meet greater energy demands. These lower impact forms of exercise may be good options during rehabilitation or to add additional metabolic energy system training to an athlete's regimen while preventing overuse injuries. These lower impact forms of exercise may be good options for options during rehabilitation or to add additional metabolic energy systems, so rowing, swimming. Recreational sports are often utilized for metabolic energy system training and may represent an enjoyable form of exercise. However, it is difficult to control and monitor acute variables such as volume and intensity during these activities. Recreational activities should be encouraged as a form of daily physical activity that contributes to overall caloric expenditure and promotes overall cardiovascular health. However, to achieve the greatest results with metabolic energy exercise, to achieve the greatest results with metabolic exercise, more control over the training environment is necessary. Therefore, modalities such as walking or running, cycling, swimming, rowing, and elliptical machines represent the most effective modalities and should be relied on more than recreational games in the performance enhancement arena. Metabolic energy system training methods. Steady state. This is an example of the methods. Steady state training can be divided into three categories, differing primarily in the intensity at which the athlete will exercise. These categories include long, slow distance, race pace, percent of maximum heart rate pace, long, slow distance, race pace, percent of maximum heart rate pace. Long, slow distance training is performed for a specific longer period of time at a low to moderate training intensity. The goal is to be able to complete the amount of time programmed rather than maintain a specific pace. This method of training improves maximal aerobic capacity. Race pace. Race pacing involves training at the same pace that would be maintained during a competitive event. For those athletes who consistently participate in endurance events, identifying this pace simply involves calculating the pace for the most recent event. For those who do not compete in endurance events, a time trial can be administered occasionally to identify a race pace. The pace from the most recent 12-minute run test can also be used. Then this pace is programmed for a certain period of time, with the goal being to sustain that pace for the entire workout. The pace from the most recent 12-minute run test can also be used. Then this pace is programmed for a certain period of time, with the goal being to sustain that pace for the entire workout. The pace from the most recent 12-minute run test can also be used. Then, this pace is programmed for a certain period of time, with the goal being to sustain that pace for the entire workout. Okay, they don't say how long. Percent of maximum heart rate. Similar to measuring a 1 repetition maximum in weight training, and using that as a baseline for loading during each workout. Calculating a percentage of the race pace enables the programming of workouts that alter stress based on maximal effort. It's a lot of words. This stress can vary between 75 and 110% of race pace for various amounts of time. Higher intensities are sustained for less time than lower intensities, with each workout contributing to the overall development of metabolic energy system training. With each workout contributing to the overall development of metabolic energy system training. Over here. For example, if an athlete sustained an 8-minute mile run during a recent half marathon, this pace could be used to create percentages of pace for training. 75% at 75% of the pace, the athlete would sustain a pace of about 10 minutes per mile. or faster paces of 110% could be performed 7-12 minute pace, but for shorter distance. Interval training. Interval training has received a great amount of research attention over the years. This training concept enables higher intensity effort by providing bouts of recovery between each repetition of exertion. Work to rest ratios can be calculated and altered to change the stress applied during each workout. Generally, ratios ranging from 1 to 1, 1 to 5 are utilized to provide adequate recovery within each interval. Higher intensity efforts and shorter recovery periods increase the training demand and add to overall stress applied. Sports performance professionals can alter both the intensity and work to rest ratios to vary training stress throughout the program. Moderately intense intervals involve exercise at a medium intensity with the goal to complete a set number of programmed intervals rather than reach maximal or near maximal effort during each iteration. Moderate intensities are best for beginning exercises. Moderate intensities are best for beginning exercisers and for occasional reduction in overall training stress to avoid overtraining. Make these workouts a great tool for day after recovery following highly intense training days or competitive events. High intensity intervals place a considerable challenge on the metabolic energy system by pushing the athlete to near maximal effort during each repetition. Longer periods of recovery are often needed during highly intense intervals to promote recovery in preparation for another bout of intense effort. These intervals are best suited for highly trained athletes or for occasional challenge to begin exercise. Adequate training and preparation time should be allowed to enable athletes to prepare for the exertion required in these workouts. Pro tip. Where high intensity interval training HIT focuses on maximal effort during each interval, moderate intensity training can also be organized with an interval-based structure. For example, 1 minute at 83%, 1 minute at 73% times 5. For example, 1 minute at 83% for 1 minute at 7. 1 minute at 7. Okay, for 1 minute. 73% times 5 in this situation used focusing on anaerobic fitness. Endurance adaptation can be achieved while still providing the fun and engaging experience an interval structure allows. Repeated sprints is a style of interval training shown to be just as effective for improving metabolic energy system fitness as continuous endurance training, only at a reduced total volume. It involves maximal efforts in repeated periods of lasting up to 10 seconds, followed by periods of complete recovery. This type of training is designed to enhance power and power endurance, while allowing the metabolic energy systems ample time to recover between each repetition or each set. Repeated sprint workouts are highly demanding. Athletes must be adequately oh boy, you got it. Repeated sprint workouts are highly demanding. Athletes must be adequately prepared by completing a considerable amount of time in moderate and high intensity interval training, along with sufficient steady state exercise to build a good foundation of fitness. Once an athlete has participated in at least 2 months of consistent interval and steady state training, they may be prepared for repeated sprint sessions. To gauge tolerance, the sports performance professionals should start with short distance sprints, 20 to 30 yards, with longer rest periods between sprints, 90 to 60 seconds. If the athlete tolerates this approach, sprint distance may be extended and rest periods shortened, as tolerated by the athlete. Page 208. It's pretty interesting. To gauge tolerance, the sports performance professionals should start the short distance, 20 to 30 yards, with rest periods 60 to 90 seconds. If it goes good, if the outcome is good, then, crank it up. High-intensity interval training is often defined as training about 90% of VO2 max for bouts lasting seconds to minutes. HIT usually involves many repetitions of these short bouts per exercise session, interspersed with rest. Interspersed with rest that can be either complete, passive rest, or active, low-intensity recovery for 2 to 3 minute bouts. Another example of HIT, one frequently used in research studies to elicit the HIT-induced effects, is a session of 4 to 6 back-to-back wing gait tests with about 4 minutes of recovery between each. This type of training induces rapid and profound changes in mitochondrial content and enzyme activity, but HIT does not produce muscle hypertrophy. Thus, despite the short duration and very high intensity, HIT specifically targets the cellular pathways involved in aerobic respiration and energy. HIT specifically targets the cellular pathways involved in aerobic respiration and energy, ATP generation, not metabolic pathways related to muscle protein synthesis. HIT has been shown to be as good as, not necessarily superior to, traditional endurance training, i.e. long, slow distance, for producing an increase in mitochondrial content in activity. But the advantage to HIT is much smaller time investment needed to elicit these adaptations. Thus, HIT is not necessarily a substitute for long, slow distance, because longer duration activities serve important functions for improving cardiovascular function, stroke volume. Thus, HIT is not necessarily a substitute for long, slow distance, because longer duration activities serve important functions for improving cardiovascular function, stroke volume, cardiac output, vasodilation, etc., and improving running economy. However, it is important to understand the mechanism of HIT-induced adaptations at the cellular level, so training can be designed to target those adaptations as needed. Specifically, HIT induces the following adaptations in very time-efficient ways, i.e. 30 total minutes of activity per week, not counting rest for 2 to 6 weeks. Increased synthesis of new mitochondria, which allows for improved fat oxidation and ATP production. Increased mitochondrial biogenesis leads to better energy production, defense of the cellular energy state, and improved fatigue resistance. Mitochondria are better able to oxidize fats, probably use fats. Sparing of muscle glycogen, prolonging time to exhaustion. Sparing of muscle glycogen, prolonging time to exhaustion, and resulting in less lactic production and delayed fatigue. As a result of these factors, there is a better defense of the cellular energy state, less lactic production, glycogen sparing, and increased fatty acid oxidation, and improved fatigue resistance, especially in type 2 muscle fibers, which have less fatigue resistance in the absence of HIIT training. And improved fatigue resistance, especially in type 2 muscle fibers, which have less fatigue resistance in the absence of HIIT training. Especially in type 2 muscle fibers, which have less fatigue resistance. Especially in type 2 muscle fibers, which have less fatigue resistance in the absence of HIIT training. Programming for metabolic energy system training. Similar to overall design and organization of training displayed in the OPT model, metabolic energy system training should be strategically planned to provide appropriate progression in stress and address specific fitness goals. To do so, 4 stages of training are followed, each with a unique training goal and the use of specific methods to achieve it. This approach ensures a long-term training adaptation based on individual readiness. Each stage generally lasts 4 to 6 weeks, depending on the time and length of the competitive season. The most common method for programming intensity based on heart rate is the utilization of training zones. By this method, intensity is calculated as percentages of predicted maximum heart rate based on the age of the exerciser. 208 minus 0.7 times age in the Carbone formula. Training heart rate is then established using specific percentages, zone 1, zone 2, zone 3, etc. Zone 1 would be 65 to 75% of your top number. Zone 2, 76 to 85. And zone 3, 86 to 95. I'm just going to repeat the whole thing again. They repeat stuff in this book many times, thinking that you're going to get it. Not right correctly. Each zone challenges different elements of metabolic energy system fitness, resulting in specific benefits of training. Zone 2 is used for recovery or low-intensity training sessions. That was Zone 1. Zone 1 is used for recovery or lower-intensity training sessions. Zone 2 is generally close to anaerobic threshold and may help to improve it, as well as better sustained training or competition speeds. Zone 3, the body must produce more energy to sustain muscle activity, thus greater. We gotta close this out. This is what Chase